Now, coming to the Huckel's rule states that, just a minute. For a compound to show aromaticity, it should follow the 4n plus 2 rule. This 4n plus 2 rule is for the delocalized pi electrons which are present in the, okay. So where n is equal to, please mute yourself. Mavia, mute yourself. Do not disturb the class. Mute yourself. Ha. So 4n plus 2 rule should be satisfied by a organic compound to show its aromaticity. So what does Huckel rule says? Huckel rule says that the cyclic unsaturated compounds containing 4n plus 2 delocalized electrons exhibit aromaticity, where n is equal to 0, 1, 2, 3, 4. So not all organic compounds it is possible to show this 4n plus 2 rule. There are few organic compounds which exhibits aromaticity. For example, benzene, for example, cyclopentadienyl anion, for example, cyclopropanyl cation. Okay. For n is equal to 0, there should be 2 pi electrons which are delocalized in the ring. For n is equal to 1, there are 6 delocalized pi electrons present in the aromatic compound. For n is equal to 2, there are 10 pi electrons which are delocalized in the aromatic compound, and so on. If these many pi electrons, these many delocalized pi electrons, if they are present inside the aromatic compound ring, then only it is said to be the compound is properly aromatic and it exhibits aromaticity. So one of the most important condition is satisfying the Huckel's rule. Okay. Then yesterday we studied about the 3 important compounds. The first one we learned about cyclopropanyl cation, C3H3 plus. By looking at the structure itself, we understand it's a cation. Okay, and it is undergoing sp2 hybridization. There are 2 pi electrons present in it. So 2 pi electrons comes under this Huckel's rule where n is equal to 0. So when n is equal to 0, 4 into 0 plus 2 is equal to 2. So both the ways, the cyclopropanyl cation is satisfying all the conditions for a compound to be aromatic. Okay. Then when it is satisfying, it is also showing us the resonance stabilization. Resonance का diagram important है, वो करना है. तो आप देख सकते हो ये वाला जो फिगर है, यहाँ पे ये cation है, so plus sign, and there are dotted circle surrounding this plus sign. This dotted circle shows that the electron is delocalized and there is pi electron cloud formed inside this particular structure. So pi electron cloud formed means what? It means that the electron is delocalized, it is not fixed, and the double bond is shifting because the delocalized electron is also shifting its position. Okay? Coming to the next one, cyclobutadiene. Cyclobutadiene is again a 4-membered ring. So it is not even a cation, it is not even an anion, it is a proper 4-membered ring with 4 pi electrons. There is no further delocalized electron present in it. And that's the 4 pi electrons. If we see the Huckel's rule, 4 is not coming into this particular table. 2 के बाद directly 6 है. So these 4 pi electrons which are present in cyclobutadiene does not obey Huckel's rule. So it is not an aromatic compound. Okay. Moving on further, cyclopentadienyl anion. Okay, C5H5 minus. Now it is a 5-membered ring structure. Here also there are 4 pi electrons present. Just दो डबल बॉन्ड है, एक डबल बॉन्ड में 2 पाई इलेक्ट्रॉन्स रहते हैं, तो 2 डबल बॉन्ड है तो 4 पाई इलेक्ट्रॉन्स है, तो 4 पाई इलेक्ट्रॉन्स. अगेन इट इज नॉट सेटिस्फाइंग, बट इट इज एन anion. Anion means it is going to accept electrons from somewhere other compound. So these two electrons are lone pair electrons. So these two lone pair electrons will also contribute to the resonance form of the structure, and also it is delocalized. So these 4 pi electron plus these 2 electrons gives us 6 pi electrons. So in all, there are 6 delocalized pi electrons present in the ring. And that's the reason cyclopentadienyl anion shows aromaticity in its behavior. Okay. So this is the resonance stabilization of the anion cyclopentadienyl anion. ठीक है, तो ये हमने कल तक पढ़ा था. रेजोनेंस स्टेबलाइजेशन स्ट्रक्चर आप सबको देखना है, करना है जब भी ये क्वेश्चन पूछा जाएगा. इट्स इंपॉर्टेंट. कमिंग टू टुडेस लेक्चर नाउ, आई होप कल जो हमने पढ़ा था वो आप सबको एक ब्रश अप हो चुका है. नाउ कमिंग टू द लास्ट पार्ट ऑफ दिस पर्टिकुलर मॉड्यूल, which is aromatic sextet theory. I hope you all have done this in your previous class.
No ma'am. No ma'am.
सेक्सटेट थ्योरी नहीं किया है? ठीक है, कोई बात नहीं. ठीक है, कोई बात नहीं. इट्स वेरी सिंपल. हम पढ़ते हैं इसमें क्या है. Sextet theory, you know, it was proposed by Robinson to show the unusual stability of the compounds such as benzene ring, then how it is cyclic in nature. Now, what it says, you know, benzene में कितने carbon atoms present रहते हैं?
6.
Exactly. Now, what is this theory suggesting us? You know, all these 6 carbon atoms which are present in the benzene molecule is responsible for bringing out the aromatic behavior in benzene. Means what? हर एक carbon atom का हर एक electron contributes to the double bond formation in the ring. Are you getting me? हर एक कार्बन एटम, जो 6 के 6 कार्बन एटम है, वो उसमें का हर एक कार्बन एटम अपना एक एक इलेक्ट्रॉन प्रोवाइड करता है रिंग के लिए. ओके, रिंग फॉर्मेशन के लिए. ओके, ये जो इलेक्ट्रॉन है, दे आर नॉट इन्वॉल्व इन हाइब्रिडाइजेशन, बट दे आर delocalized. They are delocalized. Delocalized का मीनिंग क्या है? Moving inside the ring. Yeah, exactly. It keeps on moving inside the ring structure. So imagine एक कार्बन एटम का एक इलेक्ट्रॉन, वैसे 6 कार्बन एटम के 6 इलेक्ट्रॉन रिंग में घूम ही रहे हैं. So because of this movement, what happens? You know, electron cloud is generated. Okay, so when the electron cloud is generated, when all these 6 electrons contribute to this particular benzene ring, they are called as closed sextet. Understood? And this sextet of a particular of electrons is responsible for the stability and aromaticity in benzene molecule. Just a minute. क्या हुआ? हुसैन सर, हाँ लेक्चर में हूँ, 11 बजे के बाद फ्री हो. ठीक है. अरे सद्दाम, ये लेके जाओ ना, ये एफसी का पेपर्स है. ये ना, ये सब एफसी का ही है, अपना एडमिशन में जो लिया था, ये सब लेके जाओ. ये रद्दी में कैसे क्या करना है डाल, ये रहने दो. और बाकी जो नीचे में कुछ पेपर है वो भी, वो मैंने कैबिन में. Okay, so all these electrons present which are delocalized in the benzene ring, they are responsible for the stability and aromaticity in benzene molecule. For example, these are the examples. ठीक है. अभी यहाँ पे देखो, ये 4 है इलेक्ट्रॉन्स फ्यूरान में, थायोफिन में, पायरोल में, बट इन सब के पास लोन पेयर ऑफ इलेक्ट्रॉन्स है. सो दीज लोन पेयर ऑफ इलेक्ट्रॉन्स also get involved into the bringing out those the delocalized movement and creating electron cloud inside the ring. Okay, so with this theory we move on further to study the structure in benzene molecule. So now we are going to study in detail the structure and bonding of benzene. Right from the beginning part, जैसे किसने सबसे पहले three different theories were suggested. Okay, the first theory which was suggested for structure and bonding of benzene is Kekule's structure. सुना है आपने? Kekule's
No, ma'am.
structure. हाँ.
No,
The
ma'am.
the first theory to explain the structure and bonding of benzene दिखता कैसा है, वो क्लोज्ड है या ओपन है, अगर वो क्लोज्ड है तो क्यों क्लोज्ड है, उसमें जो कार्बन कार्बन बॉन्ड है उसका बॉन्ड लेंथ कितना है, एंगल कितना है, कार्बन हाइड्रोजन का बॉन्ड लेंथ कितना है. All this was proposed in these three theories. The first one is Kekule structure, the second one is resonance structure, and the third one is molecular orbital structure, which we actually follow. Okay, so what did Kekule structure suggested regarding benzene? The full name of this particular scientist is August Kekule. Okay, when he was studying the benzene molecule, he said that it is a cyclic planar structure with 6 carbon atoms and containing alternate double bond and single bond. Okay, so simple एक structure है benzene का, which was explained by Mr. August Kekule. He said benzene के अंदर 6 कार्बन एटम है और ये 6 कार्बन एटम जो है साइक्लिक स्ट्रक्चर के अंदर है. इट इज क्लोज्ड स्ट्रक्चर विद alternate double and single bond. ठीक है, and he also said that each carbon atom is further bonded with hydrogen atom. Okay, each carbon atom was bonded with hydrogen atom, thereby making the structure as C6H6. The structural formula of benzene is C6H6 and it is highly stable. It undergoes electrophilic substitution reactions very easily. Why it undergoes, that also we will see it further, but does not undergo addition reactions under normal conditions. Okay, so when he was studying this particular structure, he said the carbon carbon single bond, the कार्बन कार्बन के बीच में जो बॉन्ड लेंथ है वो है 1.54 एंगस्ट्रॉम यूनिट. Okay, Kekule said that through his findings कार्बन कार्बन के अंदर जो सिंगल बॉन्ड है वो 1.54 एंगस्ट्रॉम यूनिट है. Okay, whereas the कार्बन कार्बन डबल बॉन्ड का जो बॉन्ड लेंथ है, ठीक है, कार्बन कार्बन का जो डबल बॉन्ड का बॉन्ड लेंथ है इट इज 1.34 एंगस्ट्रॉम यूनिट. ठीक है, दिस वाज हिज फाइंडिंग्स, but actual findings said that no matter whether it is a double bond or a single bond, the bond length is equal throughout the ring structure. Means carbon carbon double bond ho या single bond ho, it is equal and the bond length is found to be 1.39 Armstrong unit. Okay, so this was the actual finding. According to Kekule, single bond 1.54 and double bond 1.34. And also benzene possesses two orthodimensional structure. यानी कि ये जो A है डबल बॉन्ड के जगह पर, ये जो A है ये एक इलेक्ट्रोफाइल है. Okay, and there is alternate structure of benzene which is present is 1 ortho dihalobenzene. So this was the initial suggestions made by Kekule through his finding. So this was the theory proposed. Okay, तो theory कहता है कार्बन कार्बन सिंगल बॉन्ड is 1.54 carbon-carbon double bond is 1.34. But actual finding says that all the bond lengths, no matter whether it is double bond or single bond, whatever it is 1.39 Armstrong unit throughout, and it is equal in length. Okay. So with this findings, the further studies was done and the resonance structure for benzene was written. What is resonance structures? What is the meaning of resonance? It is written over there for your information. Means the phenomenon in which two or more structures can be written for a substance which involve identical positions of atom. Means what? Atoms remain in their position itself, but हर atom का हर एक electron वो movable है. Their positions are differing, and that's the reason the double bond is also shifted. Means the position of atoms remains the same, the double bond in the ring keeps on moving, and that is called as resonance. And such structures, they are called as resonance structures. Okay. Now, according to this resonating structure, as we studied through Kekule's theory, it is 1.54 carbon-carbon single bond and double bond is 1.34. Okay, and all the electrons present inside the ring, not all, carbon atom ka jo electron present in the ring, they are delocalized. Okay, and that's the reason the position of double bond in the benzene ring is not fixed. Okay. Now, how did we come to know okay, bond length is equal in the benzene ring? Through these analysis. Please mute yourself. I'm getting disturbed. तो हाँ म्यूट करो अपने आप को. Yes. We came to know through X-ray diffraction and electron diffraction analysis of benzene, which says that carbon-carbon bond of benzene have got same bond length, which is of 1.397 Armstrong unit. Most important line, through X-ray diffraction and electron diffraction analysis, we came to know that carbon-carbon bond length in benzene is equal, is same, which is 1.397 Armstrong unit. ठीक है. एंड ये कब होगा जब कार्बन कार्बन के बिहेवियर में जो है एक पार्शियल डबल बॉन्ड नेचर भी है और हर कार्बन जो है इट डोनेट्स और इट provides one electron from each side. So what happens? The 6 pi electrons, they are delocalized, they are not fixed in position, and because of which the pi electron cloud is formed. This is one thing. Okay. Now coming further with the studies, there is carbon hydrogen bond also. The carbon hydrogen bond is found to be of 1.09 Armstrong unit bond length. How much it is? 1.09 Armstrong unit bond length. Okay. So this is all about the resonating structure. Please draw this figure. Resonance structure का ये figure draw करो. Let me know if you have completed. Done?
No, ma'am.
करो करो. 53 students, 10 students are still absent. Very poor percentage of attendance.
Done, ma'am.
Done?
Yes, ma'am.
Moving further, just a minute. Moving further with the molecular structure which we are following till today also. Now coming to the molecular orbital structure of benzene. Many things we studied in the Huckel's rule and all, the same thing or somewhere or the other, the same type of words will come up. First thing is the all or what about the 6 carbon atoms? What type of hybridization, what type of bonding is there? Now, all the 6 carbon atoms of benzene are sp2 hybridized. Okay, sp2 hybridized. Now each carbon atom they form 3 sigma bonds and 1 pi bond. Let us see in the structure. This is the first sigma bond, this is the second sigma bond, and this is the third sigma bond formed. This one is the pi bond or the double bond. ठीक है, with respect to this particular carbon atom, एक carbon atom, कोई भी एक carbon atom हम लेते हैं, with respect to this carbon atom forms 3 sigma bonds and 1 pi bond. Let us see how it forms 3 sigma bonds with the other 2 carbon atoms. So ये एक sigma bond हो गया यहाँ पे. With this respect to this carbon atom, this is the second sigma bond and this is the third sigma bond which is formed. The next one and the last one is the pi bond. Okay, समझ में आया? So they each carbon atoms they form 3 sigma bonds. अब ये 3 sigma bonds में से ये division किस तरीके का है वो हम देखेंगे यहाँ पे. ठीक है? Now again coming to the same respective carbon atom, 2 sigma bonds are formed with the adjacent carbon atoms. हर एक कार्बन के बाजू में 2 कार्बन एटम्स और हैं, वो दोनों कार्बन एटम के साथ में वो सिग्मा बॉन्ड बनाता है, और जो थर्ड सिग्मा बॉन्ड है वो हाइड्रोजन से बॉन्डिंग किया गया है. So in all 3 sigma bonds. So these 3 sigma bonds are divided in this manner. 2 sigma bonds with the adjacent carbon atoms and 1 sigma bond with the hydrogen atom. Okay, followed everyone? So there are 6 carbon atoms and 6 hydrogen atoms lying in the same plane of benzene. Okay, now angle between these 2 bonds, okay, the angle between the 2 adjacent bond is 120 degree. Okay, and as I told you in the beginning itself, one carbon atom में pz orbital है which does not take part in the sp2 hybridization. तो वो pz orbital का जो इलेक्ट्रॉन है वो पूरे रिंग में घूमता रहेगा. इसी तरीके से 6 कार्बन एटम के 6 pz ऑर्बिटल्स और 6 pz ऑर्बिटल का हर एक इलेक्ट्रॉन, यानी कि 6 electrons which are delocalized and which are moving inside the ring. ओके, ये अनहाइब्रिडाइज्ड है, ये sp2 हाइब्रिडाइजेशन में पार्ट लेता ही नहीं है. Followed everyone? And all these pi orbitals they overlap sidewise to form 2 sets of pi electron cloud. You can see it over here. Okay, ये जो pi electrons है pz orbitals के, they are delocalized and they are just keeping on moving inside the ring. Okay, so continuously if they are moving, what happens? Pi electron cloud is formed. So when pi electron cloud is formed means double bond का position fix है ही नहीं. तो जब डबल बॉन्ड का पोजीशन फिक्स है ही नहीं तो वो भी मूवमेंट होता रहेगा, और वो डबल बॉन्ड जब मूव होगा दे फॉर्म रेजोनेटिंग स्ट्रक्चर्स. ऑफ कोर्स पोजीशन ऑफ कार्बन एटम इज फिक्स्ड, बट मूवमेंट ऑफ इलेक्ट्रॉन होने की वजह से डबल बॉन्ड शिफ्टिंग टेक्स प्लेस, एंड बिकॉज ऑफ दिस शिफ्टिंग व्हाट हैपेंस, देयर पॉसिबिलिटी ये हो जाती है कि अगर बाहर का कोई इलेक्ट्रोफाइल है, बाहर का कोई बग है जो अटैक करना चाहता है, वो इजीली अटैक कर सकता है because of this movement of electrons. So that's the reason benzene compound undergoes very easily electrophilic substitution reactions. Okay. Whereas agar kuch add karna hai, then it becomes difficult, but attacking of the electrophile, the negative ion is very easily possible. Okay. So here you can see in this diagram, electrophile attacks very easily at the ortho position or at meta position or at para position of the benzene ring. And these reactions, let me tell you, they are very, very spontaneous. So this is how the benzene molecular orbital structure looks like. Okay, where it says that carbon-carbon bond length is equal throughout the ring, which is 1.397 Armstrong unit. Then the carbon-hydrogen bond length is 1.09 Armstrong unit. And with respect to this carbon atom and the adjacent carbon atom, the bond angle is 120 degrees. ओके, तो कार्बन कार्बन बॉन्ड एंगल जो है वो 120 डिग्री है. कार्बन हाइड्रोजन बॉन्ड लेंथ जो है वो 1.09 एंगस्ट्रॉम यूनिट है, और कार्बन कार्बन बॉन्ड लेंथ जो है वो है 1.397 एंगस्ट्रॉम यूनिट. So this is how the structure and bonding in benzene is explained. Please do this figure. Write down the heading as molecular orbital structure, bond angle and bond length in benzene. Please do this structure. ये स्ट्रक्चर सब इंपॉर्टेंट है, जितने भी हमने बीच बीच में ये इलेक्ट्रॉन क्लाउड का स्ट्रक्चर देखा है, फिर ये इलेक्ट्रोफाइल अटैक का स्ट्रक्चर देखा है, फिर यहाँ पे हम एक्सप्लेन कर रहे हैं कि कैसे जो है सिग्मा बॉन्ड्स एंड पाई बॉन्ड्स का अरेंजमेंट जो है कार्बन कार्बन बेंजीन में, ये भी डायग्राम इंपॉर्टेंट है. So whenever you explain all these points, you have to explain it through diagrams also. Just writing the theory part is not enough. You will not fetch good marks then. Do this structure.
Done, ma'am.
अच्छे से करो, neatly करो.
No, ma'am.
Neatly करो. Yeah, I'll wait. I'll wait for 3 minutes. No, don't worry.
Done, ma'am.
All have done?
Yes, ma'am.
Okay. So this was all about the benzene structure. Now let's move on to the structure and bonding in pyrrole. Okay. Now pyrrole is again a five-membered cyclic structure. Six-membered का तो हमने पढ़ लिया. अब structure and bonding in pyrrole with respect to five-membered ring structure. So this is the structure of pyrrole. How many carbon atoms are present in it? 1, 2, 3, 4. Okay, there are 4 carbon atoms with 2 double bonds in it. How many hydrogens? 1, 2, 3,
5.
4 and 5. So what is the structure? And with 1 nitrogen, C4H5N. So pyrrole has got 4 carbon atoms in the ring, 5 hydrogen atoms and 1 nitrogen atom in the ring. Now when we look at this particular structure, there are 2 double bonds. 2 double bonds means 4 pi electrons. But then there is a negative ion present in it, which is nitrogen. This nitrogen atom always carries a lone pair of electrons. These lone pair of electrons get involved in the stabilization of the ring. So ye 4 pi electrons of 2 double bonds plus these 2 lone pair of electrons, 1 lone pair of electrons. So 4 plus 2 is 6.
6.
Yes. So these 6 electrons are nothing but 6 pi delocalized electrons. And 6 delocalized pi electrons which are present in pyrrole makes it or enables it to obey Huckel's rule of aromaticity. Okay, followed everyone? So this is how it is. The ये जो 2 electrons है, which we call it as a lone pair of electron, they also get involved. in this hybridization. So in all, there are 6 delocalized pi electrons. Now, all the 4 carbon atoms, as we saw in benzene, they are sp2 hybridized. Okay, they are sp2 hybridized. sp2 hybridized means what? 4 sp2 hybridized carbon atoms. 4 sp2 हाइब्रिडाइज्ड कार्बन एटम मतलब क्या? हर एक कार्बन, जो 4 कार्बन पायरोल के अंदर प्रेजेंट है, उसमें का हर एक कार्बन का हर एक इलेक्ट्रॉन इज इन्वॉल्व इन द delocalization of the electrons and also the bond movement in the pyrrole ring. Followed everyone? 4 कार्बन एटम के 4 इलेक्ट्रॉन और नाइट्रोजन के 2 इलेक्ट्रॉन, which we call it as lone pair of electron. The 4 plus 2, ये 6 electrons will enable the movement of bond inside the ring. So when these electrons are moving, what happens? Pi electron cloud is formed, which is lying above and below the plane of the ring. ठीक है? So ये movement होने की वजह से क्या होगा? Pyrrole shows very good aromaticity in nature. Okay, so it is heterocyclic molecule, it is aromatic molecule. There are 6 electrons taking part in the delocalization of the bond. Okay, so this is how the resonance structure looks like. एक pyrrole का आपको यहाँ पे structure लिखना है, ये दो lone electrons जो है ये आपको show करना है. So what happens? Total 6 electrons, they are moving. So when they are moving, the bond will also move. Okay, so these electrons are also moving, the bond is also moving with respect to this particular nitrogen. तो यहाँ आप देखोगे नाइट्रोजन, हाइड्रोजन, कार्बन का पोजीशन फिक्स है, they are not moving. What is moving is the electrons in the ring. And since obviously lone pair of electrons है, नाइट्रोजन नेगेटिव आयन है, तो यहाँ पे आपको माइनस शो करना है. Okay, so this is the structure, resonating structure of pyrrole. Okay, please do this particular resonating structure. First do this electron cloud structure of pyrrole. Takes time. Diagram once again I am telling, very very important.
मैम, जो हमें कॉलेज से नोटबुक्स मिली है उसे हम अपने नोट बनाने में यूज कर सकते हैं?
हाँ हाँ, वही यूज करना है ना आपको, उसी को सब्जेक्ट बुक बनाना है ना, हर एक सब्जेक्ट का, उसी के लिए दिया है बेटा. और जो असाइनमेंट शीट्स है वो प्रैक्टिकल्स और टर्म वर्क असाइनमेंट लिखने के लिए.
ओके मैम, थैंक यू.
मैम, वो जो लोन पेयर है ना, वो रेजोनेंस में पार्ट लेगा क्या? और लोन पेयर रेजोनेंस में पार्ट लेगा क्या? हाँ
हाँ, ऑब्वियसली ना, 6 पाई इलेक्ट्रॉन्स है ना, इसके जो इलेक्ट्रॉन्स है ना, बिना पार्ट लिए वो कैसे घूमेगा? ये घूम रहा है ना, ये 2 इलेक्ट्रॉन्स देखो, उसका पोजीशन चेंज होते जा रहा है. नाइट्रोजन प्रोवाइड करता है ये 2 इलेक्ट्रॉन्स को, अदरवाइज ये 4 पाई इलेक्ट्रॉन है. 4 पाई इलेक्ट्रॉन्स मींस इट इज बिकमिंग एंटी एरोमेटिक, बट जस्ट बिकॉज दिस नाइट्रोजन इज प्रेजेंट इन इट, ये अपने इलेक्ट्रॉन्स भी दे देता है, कंट्रीब्यूट करता है. तो 4 plus 2 becomes 6. This 6 electrons will keep on moving inside the ring, thereby making it resonating structure. समझा?
मैम, वो प्लस चार्ज का कैसे आया?
ये अपना इलेक्ट्रॉन दे दिया ना बेटा, तो ये प्लस चार्ज में आएगा ना, डोनेट किया,
वो बॉन्ड टूटा ना, ये वाला बॉन्ड प्लस माइनस में टूटा, तो वहाँ प्लस यहाँ इस पोजीशन में आना चाहिए ना, जहाँ माइनस है वहाँ पे.
कहाँ पे? ये सेकंड स्ट्रक्चर बोल रहे हो?
हाँ, सेकंड स्ट्रक्चर.
हाँ, तो माइनस ऊपर चला गया ना बेटा.
अच्छा, ठीक है ठीक है.
हाँ, नाइट्रोजन ने अपने इलेक्ट्रॉन दे दिए, देना मतलब प्लस साइन आना ना, और जिसको मिला वो गेन किया, वहां पे वो माइनस साइन आएगा. समझा?
हाँ, समझा.
Ma'am, can you show that resonating structure?
ये
What?
इलेक्ट्रॉन क्लाउड का स्ट्रक्चर किया आपने?
नहीं मैम, यही बना.
कौन सा कर रहे हो, रेजोनेटिंग कर रहे हो या इलेक्ट्रॉन क्लाउड?
ये इलेक्ट्रॉन क्लाउड, सॉरी.
हाँ पहले ये करो, फिर उसके बाद रेजोनेटिंग करो. Do not scribble on the screen. Done?
1 minute, ma'am.
Take your time because diagram is very important. It should be drawn very correctly. हाँ ये structures है. Tomorrow I don't have lecture in your class. Let me check. Tomorrow is Friday. अच्छा UHP है कल. Second lecture. Shall I change the slide?
Yes, ma'am.
Yes, ma'am.
Okay. I'm expecting that when I'm telling you to do something, it means it is important. That's the reason I want you to do. And though we are on virtual platform, I expect and trust that each one of you are doing the diagram. Of course, I cannot come to your place to check, but see, it is entirely each and every student's responsibility. When certain things are told to be done, written means it has to be written, followed. Make it a habit. जब आप फिजिकली क्लासरूम में होते थे तो हम लोग क्लास में राउंड लेते थे, देखते थे कौन कर रहा है कौन नहीं कर रहा है. But virtually, it is entirely the student's responsibility. Whatever teacher, your professor is telling you, you are supposed to do it. Of course, in chemistry, we will not tell you to write each and everything other than numericals. So make sure that each one of you who are present in the class today are doing this particular thing. रेजोनेटिंग स्ट्रक्चर्स लिखना बहुत आसान है, इसको बाय हार्ट करने की जरूरत नहीं है. क्या करना है, ये जो दो इलेक्ट्रॉन्स है इसका पोजीशन हर एक स्ट्रक्चर में चेंज करते जाओ. पहले यहाँ, फिर यहाँ, फिर यहाँ, यू नो, फॉर ऑल द 4 कार्बन एटम्स में घुमाओ एंड अकॉर्डिंगली डबल बॉन्ड को शिफ्ट करो. Sometimes some students find it difficult to write the resonating structure. Logically, I'm telling, if concept याद नहीं रहेगा आगे जाके, तो ये इलेक्ट्रॉन्स का पोजीशन हर एक स्ट्रक्चर में चेंज करते जाओ. हर एक कार्बन एटम पे one टाइम you keep it and accordingly alternately you have to adjust the double bond. जैसे कि ये सेकेंड स्ट्रक्चर है, ठीक है. नाउ सेकेंड स्ट्रक्चर में यहाँ पे ये वाले कार्बन एटम में लोन पेयर ऑफ इलेक्ट्रॉन्स है, तो लीव दिस बॉन्ड एंड देन पुट द डबल बॉन्ड alternately, then leave this bond and then you put the double bond over here. Especially diploma students are also over here, तो उनको थोड़ा हो सकता है कि याद नहीं हो, तो इस तरीके से लॉजिकली आप कर सकते हो. बस याद रखना है जहाँ पे ये इलेक्ट्रॉन्स है वहां ये बॉन्ड फॉर्म नहीं होगा, ऑल्टरनेट पोजीशन पे होगा. "56 are present, that means 7 are absent." Let me know if you have done.
Done, ma'am.
Done, ma'am.
All of you have done it. So with this we complete this module. Okay. इस मॉड्यूल में आपको क्या क्या याद रखना है? डेफिनेशन ऑफ एरोमेटिसिटी, कंडीशंस ऑफ एरोमेटिसिटी, हकल्स रूल. हकल्स रूल के वो तीनों एग्जांपल्स आपको करने हैं विद स्ट्रक्चर एंड एवरीथिंग. उसके बाद स्ट्रक्चर एंड बॉन्डिंग ऑफ बेंजीन एंड स्ट्रक्चर एंड बॉन्डिंग ऑफ पायरॉल. सो हियर वी कंप्लीट विथ आवर फर्स्ट मॉड्यूल. ठीक है. Tomorrow,
Okay,
if
ma'am.
I'm taking I have UHV lecture with you. Let me just check if UHV we are supposed to take, then we will take it. Otherwise, we will start with our second module, water. Okay. Let me take your attendance.
मैम ये जो आपने आज करा है क्यूल और रेजोनेंस एंड मॉलिक्यूलर, ये भी करना है?
ये तो पढ़ना ही है ना.
नहीं मतलब ये नोट्स में है क्या? मैंने चेक नहीं
हाँ
किया.
हाँ, नोट्स में सब है. नोट्स में everything is there. Whatever is taught to you with respect to your Mumbai University syllabus, with respect to the question paper, question answer pattern में ही आपको दिया गया है. Everything is there in the notes. Whatever I have taught you. Okay. You have to just prepare it properly. Time is very less. Examination has been preponed as per the guidelines of Mumbai University. See, certain things are not in institute's hand also. We have to follow their rules. But we will see to it that each and every lecture is conducted. There is no rush up. And in the end, what will happen, now if we want, move on with our good speed, in the end, we will have to take lectures on Saturdays, on Sundays also, just to complete your syllabus. In that case, you will not get time to study. तो जहां जहां पर भी शुरुआत से ही हमको कहीं सैटरडे या कहीं पर भी एक्स्ट्रा लेक्चर लेने की पॉसिबिलिटी हो रही है, वो हम ले लेंगे, सो दैट एंड में आपके ऊपर भी बर्डन नहीं आए, कुछ प्रॉब्लम नहीं हो, क्योंकि असाइनमेंट सबमिशंस बहुत सारे होते हैं और हर एक सब्जेक्ट का होता है जो कि ये 2 महीने में कवर करना है. तो यू विल ऑल्सो समवेयर गेट स्ट्रेस्ड आउट. So make sure whatever notes, whatever material of all the subjects you are getting, whether it is written or study material, do it on time. ठीक है.
ओके मैम.
या
मैम इज इट कि अगर सिर्फ हम आपके नोट्स पढ़े और कोई रेफरेंस बुक बोरो नहीं किए तो
भी चलेगा. Notes are enough. It is made with respect to Mumbai University syllabus only. That's what I'm telling again and again. Okay. You can refer reference books for getting more information, but the problem is what, when you refer the reference book and if you are studying from there, एक पर्टिकुलर क्वेश्चन आया, वो रेफरेंस बुक से अगर आपने पढ़ लिया है तो आपको ये पता नहीं चलेगा कि मुझे कहाँ से शुरू करना है और कहाँ आके खत्म करना है. अंडरस्टूड. तो रेफरेंस बुक रेफर करना इट्स वेरी गुड पार्ट, बट when it comes to your studies, refer the notes. This is what I'm telling. ठीक है. Now let me take attendance. Yeah. Roll number 1. Answer
Present,
your roll
ma'am.
call. 2,
Present, ma'am.
3,
Present, ma'am.
4. Roll number 4, absent. 5. 5. Roll number 5, absent. 6.
Present, ma'am.
7. 7.
प्रेजेंट मैम.
8. Roll number 8, absent. 9. Those who have
Present,
given their
ma'am.
attendance can leave. 10.
Present, ma'am.
11.
Present, ma'am.
12.
Present,
Absent.
ma'am.
13. Answer
प्रेजेंट.
on time. 14.
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18, 18,
Present.
absent, 19,
Present.
20,
Present, ma'am.
21,
Present, ma'am.
22,
Present, ma'am.
23,
Present, ma'am.
24,
Present, ma'am.
25,
Present.
26,
Present, ma'am.
27,
Ma'am, 23 present.
yeah, 27, 27, absent, 28,
Yes, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37,
Present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am. Present, ma'am.
40, 40,
Present, ma'am.
41, 41, absent, 42, 43, 42 is
Present.
absent, 43,
43 present. 43 present.
42 is absent, no? 44,
Present, ma'am.
45,
Present, ma'am.
41 is present, he is telling. 1 minute, huh? आंसर ऑन टाइम, हाँ ठीक है, कोई कोई चैट बॉक्स में डाल रहे हैं क्या? 1 मिनट. 41 is present, okay. 46,
Present, ma'am.
47,
Present, ma'am.
48, 48,
Present, ma'am.
49,
Present, ma'am.
50, 50 is absent, 51,
Present, ma'am.
52, 45 को मार्क किया प्रेजेंट मैंने. 52 absent, 53, 54, 53 is absent, 54,
54 present, ma'am. Present.
55,
Present,
55,
ma'am. Present, ma'am.
56, 57, 57, absent, 58, 58, 59,
Present, ma'am.
58,
59.
okay, 58 is absent, 60,
Present, ma'am.
61,
Present, ma'am.
62,
Present, ma'am.
63, 63, 63 is absent. Okay, that's all for the day. Thank you very much.
Thank you, ma'am.
Ma'am, what is the roll
05
number?
present.
Yeah,
05 present.
05 is present.
Yes, ma'am.
Just a
Sorry,
minute,
ma'am.
just answer
Ma'am.
on time better. Yes.
What is my roll number? I am Kaikasha.
Kasha, your roll number is, just a minute. You did not get you. Okay, you have joined the group late now. Kasha, your
Yes,
roll
yes.
number is 4.
Okay,
I'll
okay.
send the list once again. Okay, your roll number is 4.
Okay,
Can
thank
we
you.
leave, ma'am?
Yeah, please leave.
Thank you, ma'am.
Welcome.